Sure, ठीक है. Okay, let's start this chapter. So in
Sir,
this chapter, yes, Hayder,
sir,
yours.
my my science exam in 6th October.
6th
6th
October.
October.
अच्छा, ठीक, ठीक, ठीक. Sure. Okay, so as you can see this thing that in this chapter we are going to start in this class we are going to start this gravitation chapter, right? So gravitation is not a big chapter, it's like a small chapter, but the concepts are very important. And one more thing, everyone, that the concept in the gravitation are independent from the previous topics that we have done so far, right? So only one topic is there, which is from the motion chapter, that is the equation of motion. So in gravitation, we modify the equations of motion for the height and the acceleration due to gravity. Am I clear to all of you? Please do let me know, everyone.
Yes, sir.
Any doubts so far to anyone? Sure. Right. So, okay. So as you can see this thing, right, Farhan is having the exams on day after tomorrow. So what we'll be doing is that we will be completing the chapter without writing. I will share the notes, right? We will do the numericals in the class and I will explain the theory part from the notes itself right here. Okay, Hanan, Hayder and Farhan.
Yes, sir.
Sure, that's great. Hanan, could you please basically tilt your camera a little bit? Actually, this nice. Because chicken. Chalo, that's great. So in this, okay, now the first topic that from the gravitation chapter is universal law of gravitation. So universal law of gravitation in the simple word means that every object in the universe attracts each other. That is nothing but the gravitational force, right? It means that if I'm sitting in New Delhi and suppose that Heather is sitting in Dubai, so basically we are attracting each other. But the force is very small, right? So that's why it is not observable. But every object in the universe attracts each other, right? That's how the universe basically you can say work. So the force with which two objects attract each other is called gravitational force. Am I clear to all of you, everyone?
Yes, sir.
Sure, that's great. Okay, that is the okay. Now let's understand the next thing. So let's the next thing is the statement of the universal law of gravitation. So in the universal law of gravitation, bacho, that every body in the universe attract every body, like every other body. Suppose that Heather is there, so Heather is attracting basically the chair that is placed beside him, right? So any two body that is there, they are attracting each other. That should have some mass. So every body in the universe attract each other, attract every body with a force which is directly proportional to the product of their masses. It means that higher the mass or like higher the product of the mass, higher will be the force between those bodies, right? And inversely proportional to the square of the distance between them. It means that if you increase the distance between the objects, the force will decrease because the force is inversely proportional. It means that if you increase the distance, the force will decrease because here you can see this thing, the distance basically is square. It means that if I'm basically suppose that I'm saying I'm decreasing the force by basically I'm increasing the distance by 2 meters. So square of 2 would be 4. Yes or no?
Yes, sir.
Right? So square of 2 would be 4. So it means that so force is getting, so suppose that this is somehow this is the product of the mass. So it is getting 4. So as you can see this thing, the force is decreasing by a factor 4. We have decreased the distance by 2, but the force is getting decreased by 4. So that's why this is nothing but the factor that is affecting the gravitational force between the two bodies. Am I clear to all of you? Please do let me know, Hanan, Hayder, and Farhan.
Yes, sir. Yes.
That's great. So if I basically represent the conditions, right? So as you can see, this thing force is directly proportional to the product of their masses. It means that any two bodies that are basically attracting each other, the product of their the product of their masses is directly proportional, and distance is inversely proportional to it. So as you can see this thing, so if I merge it, basically because you can see this thing, force is on the left hand side. So on the right hand side, the properties are this. So if you merge this thing, so we are getting F is directly proportional to the mass in mass 1 into mass 2 divided by R square. Am I clear to all of you? Please do let me know. Yes, sir. Hanan,
Yes, sir.
Farhan, and Heather. Okay.
Yes, sir.
Chalo, that's great. That's great. Right. So force is directly proportional to the gravity. So if I remove this directly proportional constant, everyone. So we've already done this thing in the force chapter. Force is directly proportional to the mass into acceleration. So when we basically remove this, we got a k in the second law of motion. But here the thing that is here present, that is g, that is capital G, right? So don't get confused between small g in this chapter and capital G. So capital G is the universal constant of gravitation. Small g is the acceleration due to gravity, right? We will do this thing, okay? Just please be patient. So the thing is that do not get confused between these two things. Okay. So G F is equals to G into M1 into M2 by R square. So this is a constant that is basically that comes into the equation, right? So this constant is called universal gravitational constant, right? And the value of this universal law of the universal gravitational constant is 6 into 6.67 into 10 to the power minus 11 Newton meter square by kg square. Am I clear to all of you? Please do let me know, everyone.
Yes, sir.
Right. So this is very, very important to
Yes, sir.
understand this thing, that this is a G. And one more thing, everyone. So wherever you go into the space, on any planet, on any galaxy, somewhere, anywhere in the space, this value of G will not change. That's why the word universal gravitational constant is written over here. Hayder, Farhan, Hanan, clear, bacho?
Yes, sir.
So that's very
Yes, sir.
important. So suppose that the questions comes into the exam, that what are the factors affecting the universal gravitational constant? You will write this thing. There is no factor that could affect the universal gravitational constant because it is constant in every part of the universe. Right? Am I clear to all of you? Please do let me know fast.
Yes,
Yes,
sir.
sir.
Okay. So it is not affecting. So if you change the mass, if you change the distance, if you change the planet, if you change anything, it will not change at all. Right? This is a kind of, this is basically fixed. That's why it is called constant. You know this thing that constant does not change. Right? Constant means fixed. So it is a fixed value. Okay? Sure, that's great. Okay, now let's understand the force in the gravitational chapter. That is the most important chapter. It's the most important basically force in the gravitation. So basically this is a force called centripetal force. I've told you in the motion chapter when we were doing the circular motion, uniform circular motion. I told you about the same, that the force required to keep a body in circular motion, that is centripetal force. In the revision classes as well, we have discussed this thing. How many of you remember this thing, Vichu? Heather and Farhan and Hanan. Do you remember, Heather?
Yes, sir. Sir, I remember, sir.
Okay, Farhan, that's good. Heather,
Sir, I can't hear you.
how is it possible that I muted myself? I don't know how I got muted. Sorry, I was asking that, do you remember that I have explained the centripetal force in the motion chapter, uniform circular motion? Hanan and Heather?
Sir, can you repeat
Yes,
the
sir.
explanation?
ठीक है नहीं okay, that's great. I will explain again, no worries. ठीक है, so centripetal force is the force that is basically force required to keep a motion in a circular form, right? In the circular motion, to keep a body in a circular motion. Suppose that this body is earth, this is sun. So the sun will attract the body. This earth, sun attracts because there are two bodies, so they will attract each other according to the universal law of gravitation, right? So basically, so this attraction, okay, so this attraction is basically towards the radius. So suppose that this is the circular path. The Earth orbits in circular path, right? We know this thing that Earth orbits in circular path. It's revolve around the sun in a circular path. So it means that the force required to keep the circular motion, that is called centripetal force. Am I clear, Heather? Right. So this is the
Yes,
force
sir.
required. Okay, and each and every point. So every point. So suppose that Earth is here. So again, the force will be towards the sun. It is basically along the radius. Okay, it is towards the sun. Am I clear? Okay. So that is called centripetal force.
Yes, sir.
Centripetal is the force that is required to keep the body in the uniform circular motion. Okay. That's great. Next is for tangent is the point of contact at only one point. Basically, tangent means suppose that circle. So if I draw a line which is basically touching or which is touching the circle, touching or intersecting the circle at only one point, that is called the tangent. So that's why the only point of contact is called tangent. Am I clear to all of you?
Yes, sir.
Farhan, is this clear?
Yes, sir.
Sure. So in the exams, very basic types of questions comes into the scenario regarding this topic. That is you just have to calculate the force between the two bodies and the distance between them is given to you. And right, okay, just a second. So, Acha, please tell me one thing, Bacho, that is there any topic from the gravitation chapter that is not coming specific topic? Because I like in some of the schools that they cut there's any topic like the Archimedes principle or the density topic or buoyant force topic. So, is there any specific topic? Could you please tell me about that?
They will be taking half of the
Half of the
lesson.
so
Gravitation
they are
lesson.
half chapter of gravitation is coming in your exam,
Yes.
Hayder? अच्छा
Yes, sir.
ठीक है
I think, sir, we will not take thrust and pressure. Thrust and pressure is not coming in the exam.
which part, Hayder?
Thrust and pressure. Till
Thrust and
the end
pressure.
of the yes.
So they are asking till what is the last topic that they are asking?
Weight of an object on the moon.
Could you please speak it again,
Weight of an
Hayder?
object. Weight of an object on the moon.
Weight of the object on moon, basically weight and mass.
Yes.
ठीक है, ठीक है. Hanan, do you have any specific topic which is not coming into the exams?
I don't know, sir. Teacher has only started taking the chapter.
So they just told you that the gravitation chapter is coming.
Yes.
Sure, ठीक है, कोई बात नहीं. Okay, so now let's do this question, Heather and everyone. Okay. Let me tell you how to solve this question like this. So you just have to remember the formula that is we have studied in the as the first line. So let's identify and analyze this question, what it is asking. So calculate the force of gravitation due to Earth on a ball of mass 1 kg lying on the ground. So right. So it means that suppose this is the mass of the Earth that is given to you. Everything is given here. So mass. So I'm writing mass of the Earth as capital M. That is 6 into 24 kg, 6 into 10 to the power 24 kg, right? Mass of the ball is small m, that is 1 kg, right, everyone? And the question is saying that lying on the ground, it means that the lying on the ground means basically the ball is lying at the center of the earth, that is the radius of the earth. Am I clear to all of you? Please do let me know, everyone.
Yes, sir.
Yes, sir.
Okay, yeah. We'll complete the whole chapter, no need to worry. ठीक है, चलो guys. Okay. So here it is. Okay. So now the radius of the earth is basically R, or you can say capital R. That is equals to 6.4 into 10 to the power 3 kilometer. So 3 kilometers. So as you can see this thing, that we need the value in the meter because kilometer is not the SI unit, and even the gravitational constant basically have the meter square, not kilometer, right? So I'm going to change it. So 6.4. So I'm to get the meter, I just have to multiply it with the 10 to the power 3 because 1 kilometer is having 1000 meter. Am I clear? 3 into 10 to the power 3 meter. That is equals to 6.4 into 10 to the power 6 meter. Okay, that is great. And okay, and value of J. So so you have to write all the values specifically, right? So 6 in 6.7 into 10 to the power minus 11, and do not forget to mention the units. Okay, so by kg square. Now, what we have to do is that we just have to write the formula, that is force is equals to G mm by R square, right? So substituted everything. So 6.7 minus 10 to the power 11 Newton, no 6.7, sorry, into mass of the earth is 6 into 10 to the power 24, right? Into mass of ball is 1, right everyone? And divided by the square of the radius of the earth. Okay, so that is 6.4 into 10 to the power 6 whole square. So if you see this thing, that minus 11 plus 24, because bases are same, so they will get add up. So minus 11 plus 24 would be 13, positive of 13. So it would be 6.7 into 6 into 10 to the power 13, right? And divided by 6.4 into 6.4 into 10 to the power 12. Okay, right? So as you can see this thing, that 10 to the power 12, because 6 into the 12. So they will get multiplied. And if you take this in the numerator, so that is left with 6.7 into 6 into 10 to the power 13 into 10 to the power minus 12 divided by 6.4 into 6.4. Okay. So, and this is Newton, in Newton. Okay, the force is in Newton. Am I clear to all of you? Please do let me know, everyone.
Yes, sir.
That is F is equals to, and so they go. So 13 minus 12, because the both bases are same, they will get subtracted, right? So 6.7 into 6 into 10 divided by 6.4 into 6.4. Am I clear to all of you? Okay. So that is coming out to be somewhere around 9.8 Newton. If you basically divide them, you will get the value as 9.8 Newton. So it means that the earth possesses a force of 9.8 Newton on a body lying on the floor of mass 1 kg, right? So that you can also basically understand this thing using this formula, that is force is equals to mass into acceleration. Acceleration due to earth is gravity, right? So mass is 1 kg and the gravitational force, basically gravitational acceleration, is 9.8. So that is what, 9.8 Newton. Isn't it same? In this, gravitational basically acceleration due to gravity is given, right? So in this, we have found out that what kind of force and what is the amount of force that is exerted by the earth on our body. Am I clear to all of you? Please do let me know, everyone. Farhan, Hayder, and Hanan.
Yes, sir.
Yes,
Any
sir.
doubt so far to anyone till now?
No,
So this
sir.
is how you have to do a question in the exam. So one more thing, everyone. So this would be a 3 marker at least, or 3 marker or 2 marker. So if you just write down the given things, so you will get definitely half or 1 marks, depending on the marks of the question. If the question is of 3 marks, you will get the 1 mark for the given things. And if you the question is of 2 marks, you will get the half marks for it. Okay? Because half marks is for
Yes,
answer,
sir.
1 marks is for calculation. That's how the marks are distributed over the question. Am I clear to all of you? Please do let me know.
Yes, sir.
Okay, that's great. Next is, so when the body are very big, so when the two bodies are very big, so masses, basically the product of their masses will be large, and that's why the force will become large. Okay, so that's why the force between the earth and the sun is very, very high, is very large, because sun is also like thousands and like lakhs of kilo, like greater than the earth, right? Times greater than earth, and the earth is also very big sphere and big mass, land mass. So that's why the force between the earth and the sun would be very, very large. Am I clear to all of you? Please do let me know.
Yes, sir.
Yes.
So at least try to find this answer. At least try to substitute and can like simplify as much as you can. Let me know. We'll do this question together again. Any answer? Either Hanan and Farhan. Okay, bro. So let's solve it together. Let me tell you. So as you can see, this thing that the two bodies that are given is basically the first is Earth itself and the second one is Moon, right? So the mass of the Earth is 6.6 into 10 to the power 24 kg, right? And mass of the Moon is 7.4 into 10 to the power 22 kgs. And if the distance between the Earth and Moon, basically the distance is given to you, that is R, that is 3.84 into 10 to the power 5 kilometer. So converting into meters, that would be 3.84 into 10 to the power 5 into 10 to the power 3 meter. So that is equals to 3.84 into 10 to the power 8 meter. Okay. So we have to find the value of G is basically 6.7 into 10 to the power minus 11. And sometimes in the question, it would be given as 6.7 and sometimes it would be 6.67. So, okay, so you can take any of the value, right? If the question is saying that you have to use this value, so you have to use specifically that value. And apart from that, you could use like both 6.67 and 6.7, right? And this is Newton meter square per kg square. Okay. So that is the thing. So now let's find the values for the mass between the Earth and the Moon. That is, the force is equals to gmm by r square. Substituting the values over here, that is 6.7 into 10 to the power minus 11 into mass is 6 into 20 to the power 24 into 7.4 into 10 to the power 22, right? Okay, and divided by the distance between them, square of distance between them. That would be r square, that is 3.84 into 10 to the power 8 square. Okay, so that would be 6 to the power. If 24 and 22 both are of like bases are same, so they will get added up. So this would be 46. 46 minus 11 would be 35. Am I right, everyone?
Yes, sir.
So this would be 6.7 into 6 into 7.4 into 10 to the power minus, sorry, positive 35. Right? Divided by 3.84 into 3.84 into 10 to the power 16. I know this thing that the calculations are a little bit tough, but you have to do it. Okay? In the exams, you have to finally do the calculations properly. This is a chapter which basically which is basically heavily driven on calculations, right? So that is equals to, so they go 10 to the power 16 if you take it in the numerator. So that would be 6.67 into 6 into 7.4 divided by 3.84 into 3.84 into 10 to the power minus, sorry, not minus 35, minus 16 would be 19 Newton. Clear, everyone?
Yes,
Yes, sir.
Yes, sir.
yes, sir.
So let me basically just calculate them fast because we have some other topics as well. Into 6 into 7.4 divided by 3.84. So that is coming out to be 20 point. So force is coming out to be 20.1 into 10 to the power 19 Newton. Okay, so you can also write this thing like 2.01 into 10 to the power 20 Newton because I have taken 0, I shifted the 0 on the left hand side. So, okay, so that's why one more 10 will come here. Am I right? Clear to everyone?
Yes, sir.
Okay, that's great. So this is the value. So that's how you will find the answer. Please do let me know if it's clear to all of you.
Yes, sir.
Yes, sir.
Yes, sir.
Any doubt so far to anyone?
No, sir.
Shall I? Okay. Now let me tell you what is the basically the explanation given by the universal law of gravitation. The universal law of gravitation explains the several factors like the force that binds the earth. That means that the force that basically gives a complete like there is nothing that is basically pushing or basically binding the earth, but the force of gravitation. That's why the earth is able to complete the full revolution around this. Oh, sorry, okay, full revolution around this. Okay. The motion of moon around the earth, same explanation, because the gravitational force of the earth pulls the moon towards it, so that's why the moon is able to complete the revolution. The motion of planets around the sun, because sun is a very big mass, so that's why the motion of the sun would the basically the force of the sun exerted by the force, so that is very huge and very large, so that's why all the planets basically revolve around the sun. Am I clear?
Yes.
Yes, sir.
Yeah. And the tides due to moon and the sun, basically moon and sun also exert the pressure. They go force, like there is a third law of motion now. Every action has an equal and opposite reaction. If earth is exerting some force, so moon will also exert the same amount of force, right? So that's why when the moon exerts the force on the earth, the tides are formed, means that a huge tide in the oceans, in the sea, like about 70-80 meters high, like 70-80 foot in the height. So that's why these tides are caused in the by the basically moons and the sun. Check everyone. Okay.
Yes,
So
sir.
this is the explanation given by the central, basically the universal gravitational law. Now, next, let's come to the next topic, that is the free fall. This is one of the most important topic in the gravitation chapter, right? So in this, basically, no acceleration is basically present in the body. Just like a free fall means when the body is dropped from a height, there will be no force acting on the body, but gravitational force will acting and acceleration due to gravity will acting. So that's why this is a uniformly accelerated motion. Check everyone. In the motion chapter, there was also one question that when a body is free fall from a height, what is the kind of motion? So this motion is called the uniformly accelerated motion because G is fixed. The value of acceleration due to gravity is completely fixed. Right, everyone?
Yes, sir.
Okay, that's right. Okay. So the falling of a body from a height towards the earth or towards the surface under the gravitational force of earth is called free fall. Right? That is called free fall. Okay, so whenever the word comes, free fall means when the object falls under the gravitational force influence. Right, everyone? So as you can see this thing, suppose this is a body. So if you drop it from here, so the body will go to basically downwards, and the force acting would be gravitational force, and the acceleration would be gravitational acceleration or acceleration due to gravity. Am I clear to all of you? Please do let me know, everyone.
Yes, sir.
Yes, sir.
Is there anyone who is having doubt till now? Please do let me know. Okay. Next is the uniform acceleration produced in a freely falling body due to gravitational force of the earth is called acceleration due to gravity. So basically acceleration produced when the body is falling from a height due under the gravitational force, that acceleration is called acceleration due to gravity. Am I clear, everyone?
Yes, sir.
Any doubt so far to anyone?
No, sir.
Sure. Chalo, that's great. So as you can see this thing, the value of gravitational acceleration due to gravity changes depending on the situation and the height. So basically there are two values given, that is 9.8 or 10 meter per second square. This is an acceleration, so value the units will be of same, right? So that is the acceleration due to gravity. Clear?
Yes, sir.
Any doubt so far?
No, sir.
Okay. So G is equals to 9.8 meter per second or 10 meter per second square. So when a body is dropped freely, it falls with an acceleration of 9.8 meter per second. And when a body is thrown vertically upwards, it undergoes a retardation of 9.8 meter per second. Why? When you throw a body into in the upward direction, what will happen? At a certain point, the ball will stop and it will basically again fall towards the earth. Yes or no? So when the body is going upwards, the speed will continuously decrease or increase.
What, sir?
I'm saying when the body will continuously go in the upward direction, the speed or basically the acceleration will decrease or increase when the body is going upwards?
Decrease.
Decrease or increase, Heather?
Decrease, sir.
Decrease. Okay, Hanan?
Decrease.
Increase or decrease?
Decrease.
Decrease. Farhan?
Sir, it will decrease, sir.
Okay, yeah. So it will decrease. Okay, when the body will be thrown upwards in the direction, in the upwards direction, the acceleration due to gravity will decrease, because acceleration is for basically the force is acting, the gravitational force is acting towards the earth, not away from the earth. So that's why it will keep decreasing, and after a certain point, the value of G will become zero when the body is thrown upwards. So it will come back with the same acceleration due to gravity, that is G is equals to 9.8 meter per second square. Okay. Clear to all of
Yes,
you?
sir.
Please do let me know anyone is having doubt. Sure. Okay. So, okay. So as you can see this thing, everyone, that there are two, like I've told you that only single topic is there from the motion previous chapter, that is the equations of motion. So we have basically modified the equation based on the gravitation. So V is equals to U plus AT, right? So V is equals to U plus GT. Why GT? Because acceleration due to gravity will act in this case when the body is free falling. Okay? And we assume this thing, when the body is coming downwards, the acceleration due to gravity will be positive. When the body is thrown upwards, it would be negative, right? Because acceleration is a vector quantity. So we have to assume certain directions sign. Am I clear to all of you? Please do let me know.
Yes,
Yes,
sir.
sir.
Chalo, that's great. Okay. So and S is equals to UT plus half AT square. So H is equals to UT plus half GT square. So instead of S, we use H, because height, we have basically throw the object from a height, certain height. The body is basically starts the journey from a certain height. So that's why it will be H instead of S. So GT, again, G means the acceleration due to gravity. In this, V square minus U square is equals to 2AS. So it is nothing but V square minus U square is equals to 2GH. So that's how we modify the equations of motion for the gravitation chapter. Please do let me know, everyone. Is this clear to all of you or not?
Yes, sir.
Is there anything which is not clear to you, Hanan and Farhan and Hayder? Please do let me know, everyone. Any doubt?
No, sir.
No, sir.
Okay. Farhan, okay. Farhan, which topic, like all full, like basically complete chapter is coming in your exam?
Yes, sir. Till free fall, I think. Yes, sir.
Till free fall, they are asking.
Yes, sir.
Acha, theek hai. So, like there are only two topics. Basically, first topic is universal law of gravitation. Second is free fall.
Yes, sir.
So only two topics are coming.
Yes, sir.
Chalo, theek hai. No worries. So in this basically class, let's complete the theory for the free fall, and we will do the numericals based on the free fall in the tomorrow's class. Okay, right?
Okay, sir.
So here you go. When a body is falling vertically downwards, the velocity increases. So the acceleration due to gravity G is taken as positive. So basically, when the body is falling from a height, so the velocity will increase. So that's why we take the value of G as positive. Am I clear?
Yes, sir.
So when a body is thrown upwards, its velocity decreases. So the acceleration due to gravity is taken as negative. Okay? Because when the velocity decreases, we assume the acceleration comes out to be negative, na? Retardation. Whenever we do this thing, when the body is when the body is in motion, if you suddenly apply the brake, what happens is that the acceleration is negative, is in the opposite direction. So that's why we assume this thing, the value of G as negative in the basically in the acceleration due to gravity. Am I clear to all of you? Please do let me know.
Yes, sir.
Sure, that's okay. So when a body is dropped freely from a height, its initial velocity is zero. It means that when you drop a body like this, initial velocity would be zero. Clear, everyone?
Yes, sir.
And when a body is thrown upwards, when you basically throw a body in the upward direction, initially you have to give some velocity. That's why the body will move in the upward direction. But after the acceleration is basically at a certain point, or you can say the highest point, the value of velocity would become zero, because at that point, the highest from that point, the body will come towards the earth. That's why at that point the velocity will be zero. Otherwise, the ball will go in the upward direction, basically without basically any resistance. So it is not possible if you throw a body into this, if you throw a body in the upwards direction. So obviously it will come back to the earth, right? So that's why the velocity of the final velocity of the body would be zero. Okay. And one more thing, the time taken to rise up to the highest point is equals to the time taken to fall from that same point. If you suppose that, everyone, that if you are, this is the time of ascent. Ascent means to ascend. So when you throw a ball, so it will basically reach to a certain point, right? And it will basically come back to its original point. That is called time down, is called time descent. So both time would be same. Time of ascent is equals to time of descent. Am I clear? Suppose that if the body is taking 2 seconds to basically grow up, to go upwards to a certain point, so from that point the body will take 2 seconds to fall from that point. Am I clear to all of you?
Yes, sir.
Any doubt so far to anyone?
Sir, can you
No,
repeat
sir.
the last part?
Yes, Heather, you said something, Vijay?
Can you repeat the last part?
Okay, I'm saying that if you basically throw a body in the upward direction, so it will take certain amount of time to reach the highest point, right? So suppose that I'm standing here, I've basically thrown a ball in the upward direction. So the ball reached to the highest point in 3 seconds. So ball will take again 3 seconds from that point to come back to the basically position of mine. It means that earth towards the surface. It will take 3 seconds. It will not take 3.1. It will not take 3.2. It will take the same amount of time that is taken by the ball to reach the maximum point. Am I clear?
Yes, sir.
Any doubt so
Sir.
far to you, Haider, Hanan and Farhan?
No, sir.
चलो ठीक है, just a second. I hope this is clear to all of you. Please do let me know, everyone.
Yes, sir.
Any doubt so far to anyone?
No, sir.
Sure,
No, sir.
that's great. ठीक है? Sure, that's great. That's great.